Okay, I had a request for number 67, so I'm going to go through this problem. This was from the 2-8 homework, which I believe was on page maybe 330, something like that. I don't remember exactly, but anyway, I'm pretty sure it was from the 2-8 homework set that I had sent out. So anyway, we're asked to find the derivative of this. Okay, so it is kind of messy, but the first derivative is not too complicated, but there is a lot of algebra in this. So once we do the first derivative, we're going to have a lot of steps of algebra. So bear with me here. Pause the video if you need to make sure that you get all the notes down and all that good stuff. So all right, here we go. Now, because these two functions are being separated with a plus sign, we can do the derivative of this one first, and then we'll do the derivative of this. So I will do them in different colors so you can see which derivative I'm on. All right, yeah, here we go. So the first one, we have quotient rule. So we're going to do low d high, which means the derivative of the top is going to be a negative. Okay, 1 over the square root. Sorry, 2 times the square root of x squared plus 1. And then we're going to multiply that by the derivative of the inside. X squared plus 1 is 2x. Okay, so low d high minus high, so negative square root of x squared plus 1. D low, the derivative of x is just 1, so you can put times 1 there if you want to. And then we have plus, now the derivative of the red function, or the function that I have written in red there. Our derivative of ln is just 1 over that, so it's going to be 1 over x plus, since this is all in parentheses, all of this stuff goes on the denominator. So x plus the square root of x squared plus 1. And then the top is just the derivative of this. So the derivative of x is 1 plus the derivative of square root of x squared plus 1. We already know that because we did it right here. Okay, so it's going to be 1 over 2, try to squeeze all this in here, square root of x squared plus 1, and then times the derivative of the inside, which is 2x, finishing out our quotient, or chain rule. So right there, the calculus is finished. Okay, we're done with calculus, and now we're just doing algebra from here on out. But like I said, it can be a little bit of a messy algebra problem. So just go through and do some simplifying here first. So I can cancel out these 2's. I can cancel out these 2's just the same. Okay. So what did I do next? All right, so just kind of simplifying this whole thing here. So negative x times x would be x squared over this denominator, so square root of x squared plus 1 plus this in here, we have square root of x squared plus 1. Okay, so that's all the blue stuff. And then the red stuff, we have plus, I don't think I did a whole lot with this one here in the first step, just kind of tried to make it look a little nicer. X plus square root of x squared plus 1, and on the top I have 1 plus x over square root of x squared plus 1. Alright, so I'll try to do a little bit at a time here instead of a bunch of different steps. So there's our first step. Excuse me. I'm sorry, I actually, now that I'm looking at this, completely forgot. Let me back up here. When I did my quotient rule, I did low d high minus high d low, but I forgot that this is all over the denominator squared, and my denominator is x, so this should all be over x squared. Which means this part right here should all be over x squared. All right, that's better. Okay, so let's simplify this numerator. Okay, so we need to have a denominator of x squared, square root of x squared plus 1. So that means I'm going to multiply this one over here by square root of x squared plus 1 over square root of x squared plus 1. Okay, which is kind of nice because that square roots will cancel out there. So what do we have now? Well, y prime equals negative x squared plus, now when you multiply these two, you're just going to be left with x squared plus 1. Well, that's nice because our x squareds are gone. And we have one common denominator of square root of x squared plus 1. And we still have this x squared on the denominator of the big fraction, so big fraction x squared. All right, plus. We can do a similar thing over here. Multiply this 1, because we're trying to get x squared of x squared plus 1 over here as a common denominator. So I'm going to multiply this again by square root of x squared plus 1 over the same thing, square root of x squared plus 1. So what that will give me now is square root of x squared plus 1 plus x all over, what do I have? Wait. Well, I mean, this is still part of the numerator is square root of x squared plus 1, and then we got big fraction. We still have this stuff on the bottom of the big fraction. So big fraction x plus square root of x squared plus 1. Okay, like I said, if you didn't believe me this was messy algebra to begin with, you do now, because we got fraction and a fraction here. So let's start simplifying. So we have a negative x squared plus x squared, so that's gone. All right, so y prime, this over here all simplifies to, let me shorten that up a little bit. The numerator of the numerator is 1. The denominator of the numerator is square root of x squared plus 1. And then big denominator is x squared. Now this one over here, I kind of simplified this in this step. I multiplied the numerator and denominator by 1 over x plus square root of x squared plus 1. Multiply this by 1 over x plus square root of x squared plus 1. Okay? Okay, now this is over 1, so this just cancels all this out. And actually in the numerator then, we can see the x plus square root of x squared plus 1 is in both of those. So now all I'm left with over here is just 1 over this, square root of x squared plus 1. So 1 over square root of x squared plus 1. Okay, I'm going to do a similar thing over here, and I'm going to multiply this by 1 over x squared. Do the same thing on the numerator, multiply by 1 over x squared. So these are gone. Let me extend this page a little bit further here. So now my next step, I have y prime is equal to 1 over x squared, square root of x squared plus 1, plus, and this over here is just 1 over square root of x squared plus 1. Now we need a common denominator. I'm going to combine this together to simplify. This one has, they both have a square root of x squared plus 1, but this one has an x squared and this one doesn't. So I need to multiply this by x squared over x squared to get my common denominator. We're almost there. Hang with me here. We got another step or two. So my common denominator is x squared times the square root of x squared plus 1. My numerator is 1 plus x squared. So 1 plus x squared. Now the only other thing we can do to simplify this is I have an x squared plus 1 This is raised to the first power. And I have a square root of x squared plus 1. So that's like x squared plus 1 raised to the 1/2. Okay, you can rewrite it like that if you want to, but basically what we're going to do is subtract those exponents. So 1 minus 1/2 gives you 1/2, which means I have x squared plus 1 raised to the 1/2 all over x squared, which we could simplify that to, or not really simplify, but rewrite it as x squared plus 1 all over x squared. So that is your final answer, and like I said, the calculus was done in one step, and it wasn't too excruciatingly painful, hopefully, but the algebra is like crazy algebra, okay? So there's so many different steps in here to go from, our first step right here of when we did the derivative, and then it was algebra, 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 lots and lots of algebra to get us down to this, was our final answer.